here's what you will need for the second part of the morning. You should have Open Refine. Okay, Open Refine. Open Refine. Open source. It's gone through a couple of different iterations. It's a very nice, kind of free, powerful software for some data cleaning, munging, and even a little bit of analysis, but we won't get too much into the analysis with it today. So, yeah. So what you should do is maybe go to the Etherpad and make sure that you have the data file that we'll use. Okay, it's here in the Open Refine data file. Just make sure you have that downloaded and that you know where you can get it. And then open Refine. And again, Open Refine is a program that runs on your computer. It's very similar to the Jupyter Notebook that you'll see later, in that it will open in a browser, but you don't need to be connected to the internet to use it. It just launches through a browser, and you should have something. You won't have the files and things, and I should probably just delete these, but this is what Open Refine will look like when it's open. Okay, so why don't you just make sure that you have that data file and that you're able to open Refine. And when you're ready with those guys, give me a green sticky. This is my first time opening Open Refine. I don't have any projects existing here. What we're going to do is we're going to create a project. So if we go up to the left corner here, we click Create Project. You see that you have the option to choose a file from your computer. Let's go ahead and choose that file that we just downloaded. Click Next, and what we'll see is it will give us a preview. Okay, so this isn't our project yet, but it shows us what our project will look like. So you notice that we have the option to choose different kinds of separators here. If we had opened a tab separated file and had chosen comma separated files, we would see that in the preview that there was a problem, and we could make that change. Okay, so before we actually start the project, it gives us an opportunity to make sure that we've loaded it in appropriately. So from here, I can just go ahead and choose Create Project. And it created a project with the name of that data file, portal_rodents_1977-2002, sign name, UU, IDs, CSV. And this is just a little bit expanded version of the data that we were looking at before. Again, it's about some little critters, observed, measured. Yeah. Okay, so right now you should have your data read in. New project created. Everybody good? Yeah. All right, excellent. So Open Refine is the first thing that's very nice about it, is that it will keep track of everything that we do for us. Okay, so we don't have to rewrite a series of notes about the steps that we took in our data analysis or in our cleaning process. Okay, it's going to keep track of those for us. It also has some nice kind of organization features. So let's look at the first one of these, which we're going to call faceting. And if we click on the scientific name column, and we'll choose to facet this, and we will do a text facet. We see a window appear in the left corner of the screen. So what did the faceting do? Like, by faceting this scientific name column, like, what does it show us?
All of the different options for how many times it occurs.
Yeah, exactly, right? It tells you what the different values in that column are and how many times they occur. Now, do you notice anything that is maybe of import after having done that? Like, do we see anything here as a result of that?
Like duplicates that might be improper spelling?
Exactly, such as like these three, right? We have this, Amospermophilus, right? And then
Can you just do Apple Plus?
Yeah, sure.
Times? I think it'll just help everyone see it. Awesome, cool.
And so we have these three names that are that I think should all be the same, right? But we notice that there's some misspellings or some difference in them at the present time, right? So that's one reason to use this faceting. Now, how we can fix that is using a cluster function. So you notice that once we have these choices, we also have the option for this cluster button. And if we choose this cluster button, what comes up is, well, what do you think that it was doing with the clustering? Yeah, it's looking for kind of similar entries, right? And to group these similar entries. Okay, now there's a bunch of different ways that the clustering can happen here in OpenRefine. All right, and that's what we choose with the method and the keying function. Okay, so if we choose key collision and metaphone 3, we should end up with a different set of clusters. So if I wanted to resolve, for example, that spelling problem that I saw before, right? It noticed those three entries as a cluster here, right? It picked those out. And what I can do is I can say, okay, yeah, they should be the same thing. And I can do that with the merging function. So if I want that, I can go ahead and merge it. And just need to zoom out here for a second. And then I can say merge selected and close. And by doing that, it'll pop those together. And you see that my choices over here in my window, my facet window, they changed, right? It was 20, I had 28 different entries. And now after clustering those and merging them, I only have 26, right? So those three went into one, all right? So go ahead and play around a little bit with the clustering choices and see what else you can surface from kind of maybe redundancies in the data. Just be careful. Don't actually merge and commit what you find. All right. Just because we're going to do some later operations, so we want the data to remain in this form. But just go ahead and see what comes of changing some of those options in the clustering choices.
The nearest neighbor.
Right? And one entry was uppercase New York, one entry was lowercase New York, right? We can see that discrepancy and we can combine those values very quickly and easily. Maybe I spelled girdle, some of the times I used an umlaut, some of the times I didn't use an umlaut, that's the 2 points over the O, right? Like it would pick up those similarities, okay, and allow me to kind of group those things together. Very nice functionality here. Again, the different choices are different ways of performing clustering, okay? There's a whole bunch of different clustering algorithms out there that you'll probably experience more as you get into data science a bit, but that's all that we're doing is just choosing different ways to say these things are alike or like each other. Okay, so the next function that I want to use is the split function. So for example, like we were discussing before, if we have a column like this scientific name, one of the principles that we violated here is that there are two pieces of information in this one column, right? I believe that there is both a genus and a species, something like that. So what we want to do is we want to split that column. Okay, and we want to make it into two separate columns. And we can do that with a nice easy function. There's a split function. So if we go ahead into and click on the cells, the top cell in scientific name, and we go to Edit Cells, and we'll see, what am I doing here? Sorry. Want to split, and I'm going to change this separator. Okay, the separator that it gives me is a comma. So if I left this, it would just break it into columns based on wherever there was a comma. But we're not interested in splitting it based on a comma. What would we be interested in splitting it based on? A space. So we'll just change this to a space and hit OK. And let's see what happens. So that wasn't the split that we wanted to use, was it? No, it didn't do what I wanted it to. So we can go back to, again, this is a very nice feature of OpenRefine, is that it keeps track of all of our work, and we can easily go back to the previous step. So if I want to, over here in the left corner where we had our facets, if we click on the Undo Redo tab, right, you see that first I had split the multi-valued cells in this column. I didn't want to do that. I did something wrong here. I chose the wrong split. So if you just click back on the step above, it will undo that previous step. And now we're working with our earlier format of the data. And if we click on Scientific Name Now, and we go to Edit Column, and we say split into several columns. And again, I'm going to change that separator from a comma to a space. And I'm also going to unclick remove this column. Okay, I want to keep that original column there just in advance of doing some other things. All right. So again, we've done two things. We changed that separator from a comma to a space, and we're also clicking this, unclicking the remove this column. And now if we click OK, all right. So talk to the person next to you about what happened and why. Is that the split that you expected? Why? Why not? What do we think? How many? Here's my original column, right? And then how many other columns did I get as a result after having split that?
You got 6 columns. 3, actually. 3.
I got 4, I think.
No, you got 6.
I got 6?
Yeah, I got 6 too.
There are 6. Yeah, what's going on here? Why in the world did this split? I mean, how many were we expecting it to split to?
2.
To 2, right? Just the first name and the last name. Right? But why do you think that it would have split like this? Like, why did I get empty, name, empty, like, what's going on? Extra spaces, yeah. So we can remove, this is a common thing, maybe we have some trailing or leading white space in an entry. And we have a nice function to undo that. But to begin, let me go ahead and undo that split. So I'm going to go ahead and go back to my data without it split in that manner, okay? Just in the Undo Redo tab, click back up. And now if I go to my scientific name column and I say a common transform here, I look at the common transform, what's that first one that comes up except for to trim leading and trailing white space? So let's go ahead and use that on that column, trim the lead and trail white space, and then perform the split again and see if we get what we wanted. You're able to get a column that has the first name and a column that has the last name, and that's it. Just 2. Okay? All right, real quick, if I wanted to, maybe I want to rename this second column to species. Why don't you go ahead and try and rename my second new column to species, and tell me what happens. Try and rename this to species. What happened? Okay, yeah. There's already a column. There's already a column called species, right? It won't let you rename it. So, how could you solve that problem? Like, what's to be done about that? Real species? Yeah, sure. You can add some sort of descriptor to it. You know, a non-abbreviated species or something. Look at what the other species column is and name it appropriately, right? Like here is our species column that exists already is just AB, right? Whereas that means Amphispisa bilinita. I don't know. I'm not a biologist. I'm sorry.
Sounded right.
So, like if you do it, it's case sensitive, is that correct? So you could have like a lowercase species and a capital species in the same.
You could, yeah. What would you want that?
No, I mean, of
Yeah,
course not. But,
yeah.
Okay, so you just page one.
Yep. Yeah, no, it's the column names in OpenRefine are case sensitive. Yeah, for sure. Great. All right.
Could you show us how to, we're trying to find it, but we can't find something to edit the actual column?
Oh, like, so rename this column in the edit. So if I try to rename this to species, right, it says that another column already exists, name that. So if I rename it to species underscore full name or something, it lets me do it. Okay. I'm going to go back to before having split my cells and renamed them. All right, so we saw how to split. We saw how to get rid of that leading and trailing white space. Let's go ahead and undo that and bring it back to how it was with both of these together. Okay, so you should just have now one column, that's the scientific name, with first and last names in it. Okay, and again, all you have to do is go over to the undo redo. Okay, the next thing that we're going to look at is called filtering. So if we click in the scientific name column, all right, and we look at the text filter, we should again get this little guy to pop up in the left screen here. Let's look at
Sorry.
Yeah, sure. Okay, so again, what I did is I just, clicking on the scientific name column, went to text filter. And in that text filter, let's type BAI. Now, how many things matched that? 48, right? Yeah, it shows me here that there were 48 matching rows. And if I want to see all of them, I can go ahead and change the view to be all 50 rows by clicking on this 50. And, well, you're not going to be able to see all 50 of my rows at once here. On your machine, you should be able to see all 50. Okay? So tell me what scientific names are selected, and maybe think about how you could restrict that filter to get only one of those scientific names. Just take a minute and look through the 50 names and see which ones were selected and try and think about how you would limit that to only one of those names that are taken. Yeah, there's two, right? And if we look at them, we can see that both of them have BAI, but the second word in the second entry is the BAI start, right? So how could we hone in on one of these two? Well, maybe just add another letter, add the O, right? Add a capital, all right? Maybe what we could, if we had split these columns before and then searched for that, it would have also only gave us back one of those, right? If we were searching for the first name or in the last name, because that's where the kind of change happens, right? Okay. We can also include or exclude entries from this. So I'm going to go ahead and X out of my my text filter here. Okay, and you see that brings me back to my original data setup. Let's go ahead and look at that scientific name column again. Let's go to facet. Let's do a text facet. And now notice that if I scroll over any of these species, I also have the option to edit them, but also to include or exclude them. So, for example, if I go ahead and include my the harisi that I clustered before, right, and click on that, well, now all I'm looking at is the data for that species. Okay, so it will. This is one way to kind of get in there and filter and display only a certain data entry that you're looking at. Okay, with the include and exclude feature. So go ahead and why don't you go ahead and try and include or exclude one of the species that we were just looking at through that text filter of BAI using include or exclude. See if you can pick just one of those species using this include or exclude feature.
Oh, that's something else, so I thought you were trying to.
All right, so these exercises are meant to show you two different ways of kind of engaging with the data set through faceting and filtering, right? Faceting gives you a big picture of some kind of variable, right? This showed us all of the different species names that were there. Whereas filtering, what we're able to do is we're able to select specific rows according to some kind of criteria, all right? That's vocabulary that you'll find in some other computing contexts, in the tidyverse in particular. Okay, filter means to select rows. Also, yeah, and faceting, if you're plotting in R, faceting will create plots of different variables, okay, or different entries, categories of variables, okay. So you'll see these words other places, but this is how they work in OpenRefine, okay, with the
Repeat the definition of faceting and filtering.
yeah. So what faceting does is it gives you a big picture of some sort of feature column, okay. So when we took species name and we facet it, what it will do is it will break it apart into the unique entries. Filtering, maybe we want a specific name within that column, so we can hone in on that specific name rather than seeing all of the names that are available. That's the difference between them. Faceting shows you big picture, all of it. Filtering is to hone in on a specific entry within it or variable. Okay. Yeah. Okay, something else that we may want to do is to sort the data. So let's go ahead and look at the day and sort this column. So let's see, sort is the choice here. And I have the option to choose what kind of thing is being sorted here. So let's see, what kind of thing are these entries in this column? Well, the default is going to be text. So I would sort this right now is a text value, right? If I tried to sort it, if I go back and undo that, notice that nothing's changing. The reason that nothing's changing is because sorting isn't actually like changing anything about the data, right? It's just sorting it. It hasn't actually changed anything. So if I want to sort this based on numbers, it's not going to, it wouldn't change anything. They're not numbers. They're in here as text. So in order to change this, I have to go ahead and change it to a number. Let's go ahead and see what changes about the cell if I change this to a number. So transform to a number, and what happened?
They all became right aligned.
Yeah, they moved over and they changed color, right? So I can see just by looking here, I can see which of my columns are numbers and which aren't at this point, right? Sorry about that. Okay?
But my month was already a number, so you're saying that it wasn't a number?
It was entered as text.
It was considered as text, even though it's in there as like you see it as a numeral, right? Like it's a number too, but OpenRefine is considering everything, like blankets everything as a text entry to begin until told otherwise. So by changing this, we like that allows us to sort it on a number, okay? Like before, I would have had to sort it on text, or it wouldn't have recognized anything. I should have done the number sort first, so we would see that. But now here I am. Okay, so your goal is to try to sort these chronologically. Like right now, I just have my month sorted. What we would like is probably to understand chronological sort, where month and year at the very least kind of together combine to give us a sorting. All right? So try and use the sort options in order to put both the month and year together in a sorted kind of way, right? That we have the first month of the year and then the next month of the year and so on. So we're sorting across two columns here. I wonder if you can kind of play with the sort function to see how to accomplish that.
So do we want to create a new column?
No, I just want the data sorted, again, chronologically by month and year. So like whatever, our first year, I think, is 1977. We should have the first month of 1977, the second, and so on, and then continue on into the next year. So one thing that I used here when I was sorting my columns is if you notice when you choose the sort, there's this option to sort by this column alone. So like if I go to the year and I sort by that column alone, what it will do is it will undo my previous sort, and then I can go to month and I can sort the month, and I won't click sort this column alone, and then I should have kind of my months in order with my year, okay? So like you can choose whether or not to sort just within a single column or to choose to sort everything based on on that column, all right? And using both of those together, we could get the things in chronological order like this. Okay. Also, after we've sorted, we can go ahead and undo it with the remove sort. Okay. Notice that after you've sorted a column, the choices in the sort menu change. Like now, because I'm clicking in this column that I've already sorted. Right? Now I have different choices here. I could either sort that again, sort that sorted column some way, I could reverse sort it, or I could remove the sort. All right? So I'm going to go ahead and remove the sort. Okay, so we talked about transforming cells into numbers. Let's go ahead and change, make sure that record ID and the period column are both numbers. So let's edit common transform to number. Again, that's record ID, make it to a number, and period. Okay, so just make sure that you have both your record ID and the period as numbers. And then let's go into the record ID column, and we're going to do a scatter plot facet now. So let's click the scatter plot facet, and okay, I got this record ID and period plot. So it created a scatter plot of these numerical values compared together. Why don't you go ahead and change a couple more columns to numeric type and redo the scatter plot facet. So after you have a few different columns in there that are numeric columns, you see that it generates a larger scatter plot matrix, right? It pairs off all of those the columns with numeric values like that and creates a scatter plot. And if you have a bunch of these and you knew which ones you wanted to hone in on, like if I wanted to hone in on what's this, record ID and period, right? Like then I could just click on that individual one and it'll bring that into its own window here. And then you have options to do transformations, right? If you wanted to look at it as on a logarithmic scale or change kind of the orientation of the axes, change how the points look, and so on, okay? Similarly, you can export your plot for this scatter plot here, all right? We'll see much better visualization tools with Python, but this gives you an idea for how to compare kind of some variables quick and dirty, and then how to kind of focus in on them. All right, so the last thing that I want to show you is that suppose that we have a number of data sets like this that we're going to conduct the same kind of cleaning and organizational work on. What we can do is, because OpenRefine has saved all of our work, we can simply extract this as a JavaScript file. And we can reuse it with a different data file in OpenRefine. So let's go ahead and do that. Let's extract, if I go into my undo, redo tab and extract this, what I see is, I'm just going to zoom out here for a second. I see a bunch of JavaScript that's showing me like how, yeah, sorry my screen's not that great right now, but these are the different transformations that have happened, and here's the record for them in JavaScript. So if I wanted to do all of these again, I can just copy and paste everything over here and put it in a text file and load that into a new OpenRefine file, apply it, and those same transformations have happened. Okay? So let's go ahead and try that. You should have a clean copy of your data on your computer. And let's go ahead and copy and paste this into a text file again.
If you want to just do the Apple minus, and then it'll show it all again on the screen. Or it should.
So I'm just gonna, but if you just copy, I'll just Command A and copy all of this. I'm gonna create a new text file and paste that in here, and I'm gonna save this as, I'll save it as refine.
So what you guys are looking at, that is JavaScript, and specifically that's JSON, which is how you can structure data in JavaScript. And we're teaching this too because when we go into Python, you can use JavaScript files with Python, so it's a great introduction.
So this one, I have a question. So this Python, this one is good at cleaning data, actually, right? And then we can use SPSS, transfer the data after you cleaning the data, and then you can use into the SPSS.
Exactly, yeah. So the one other thing I'll show you is how to export this as a CSV file. But right, the idea here is that OpenRefine is very nice for kind of data munging and cleaning and transformations and stuff. Then once you've done that, you can save it as a CSV file, bring it into another program for analysis. Yeah, absolutely. You can certainly do analysis in OpenRefine, but we're not going to get into that. We're just kind of investigating it as a tool for cleaning and organizing data.
I will add in the SPSS comment. When you start learning Python, we're going to get into some intermediate calculations this week, but not super advanced, like the 3-month program where you do data science. But in those programs, you can do everything in SPSS better and faster with Python. Ultimately, if you grow into like doing data science with Python or R is great too, but we're teaching Python here this weekend, you can get rid of SPSS, never use it again, and load everything faster and better in Python, and it's free.
How transferable is the knowledge of Python to using R? Are there consistencies?
All the packages are different. The syntax is different. Some people prefer R, some prefer Python. In my opinion, and in truth, 80% of companies are Python shops.
Right.
Python, you can also build apps and you can do data, so it's way more applicable. And if you're looking for a job, everyone hires in Python.
Yeah.
R is really good. Don't fear, like if you are an R coder and you've worked in R today, very hireable in R. And some companies say you can use either R or Python. So both are good. It's just Python's more universal.
Okay, awesome, thank you.
Sorry, what is SPSS?
Okay, so those of you who've come from the stats background, this software is like SPSS, Minitab, Jump, MATLAB, Stata, and so forth. They're all
Proprietary, yeah.
softwares, but they all cost, as a student, it may only cost you $5,200 a year, but as a professional, it costs $500 to $3,000 a year, so they're not open source, and Python's open source free, so we're like empowering you with free software.
Yeah. And I would say, and just to piggyback on what David said about Python and R, I would encourage everybody to learn both. Like, they both have their strengths and weaknesses, and it's really not that different. They're very similar for the most part, but there are things about R that are nicer than Python, and there are things about Python that are nicer than R. And sometimes, it's nice to have those other things together, but they're not incredibly different. Like, if you know one, you'll be able to make your way through the other. So okay, so we've got some script saved, hopefully, as a text file. Now all I want you to do is to go back to OpenRefine and start a new project with that clean data. So if we go to Create Project, and now choose, and I'll pick that same clean data set. Looks good. And this time I'm gonna name my project using script. Create it. All right, now if we come into undo redo, right? I can take and put this code right back in to a new OpenRefine. Let me this a little bit. Project. Okay, so this should be the data as it was before, without the transformations that we did, and by popping that code from the other project in here and applying it, I should be able to then have the resulting data look like it was before. So go ahead and see if you can't execute that JavaScript to make it do and make the original data set look like the result of what's happened after our transformations. I re-uploaded that CSV file here. I go over to undo redo. I'm going to say apply, and I have I copied that JavaScript already, so I just pasted here from that text file. I hit perform operations, and now, you know, I mean, I hadn't done a lot to my data set, but I do see that at the very least, these columns have changed to numbers, and it's implemented the kind of tracking that I had before. So those steps that I had gone through in the other project, now I have them in this project as well, okay? So maybe you have like these 10 data files that are all similar. You need to repeat the same kind of operations to them. Here's one way to do it in OpenRefine, all right? Again, this is kind of a step up from our first conversation in that this keeps track of the analysis for you, and it moves it from one project to the other, okay? You can replicate cleaning and munging pretty easily with OpenRefine, all right? If you want to see more about OpenRefine, like how it uses the regular expressions and how you can kind of dig into it and do a little bit more refined kind of cleaning and munging, just go to the openrefine.org website. There's a couple of great tutorials there. If you Google and YouTube have a bunch of other stuff, okay? There's a number of links to some OpenRefine activities in our lessons and up on the Etherpad. If they're not already, we'll put them up there, okay? All right, so that was our morning. Now it's time for lunch, and when we come back from lunch, David's going to get us into Python, which is super exciting.